students, good morning. Myself Nidhi Khetia from Faculty of Pharmacy, Dr. Subhash Technical Campus. So today's our study of the subject that is Pharmaceutical Organic Chemistry 1. That's called is BP202 TP. So in this subject we learn our third chapter, that is alkenes. Okay, so we all knows that alkenes are the also known as the hydrocarbons. So today's our study of the content that is chemical properties of the alkenes and application of the alkenes. So we already learned the first two chemical properties. Now today we learn the third property, that is oxidation reaction of the alkenes. Okay, so oxidation reaction upon the nature of the oxidizing agent, alkenes are readily oxidized, forming different products. Okay, so some important oxidation reaction of the alkene, that is oxidation with ozone and ozonization, then hydrolysis, then hydroxylation, then oxidation with the hot KMnO4, then oxidation with the para acids, and then oxidation with the oxygen and air. In oxidation with ozone and ozonization process also include the reductive agents and oxidative agents. Okay, so in ozone and ozonization process, this addition of this ozone to alkenes is called the ozonization process. So this process called is the ozonization. Okay, addition of the ozone in alkenes. So this reaction is carried out in the presence of the inert solvent like CH2Cl and then CHCl3, then CCl4. Okay, at lower temperature 196 to 200 Kelvin. Okay, so ethylene plus O3, that is ozone, and then this process is the ozonization process. Okay, so in the presence of the CH2Cl2, that's called the CH2Cl2, and at a lower temperature, that is 196 to 200 Kelvin. Okay, so molozonide, making the molozonide, that is unstable product of the ozonide. Okay, and then further stabilization process and making the ethylene ozonide. Okay, so this is a ozone to ozonization process. And in ozone and ozonization process, reductive cleavage, that is a breakdown by the reductive agents. So after the ozonization process, reducing agent like Zn and H2O to forms the aldehyde or ketone or more mixture of the both depending upon the structure of the alkane. Okay, so we takes the ethylene plus ozone, that is the ozonization process. And after the ozonization process, then making the ethylene ozonide, and then Zn and H2O, that is reductive agents, and cleavage the Zn and H2O and making the one formaldehyde, that is methanol, one aldehyde making. Okay, this is a reductive cleavage. And now we study the oxidative cleavage. So if the ozonide are decomposed only with the water and the H2O2 and produced during the reaction with the oxidize the initial formed aldehyde and corresponding acids. Okay, so here we take the butene, and after the ozonization process and reduction process, making the one formaldehyde and one aldehyde and one acid are the removed, corresponding acid are the removed. Okay, now second one, that is a hydroxylation. In this reaction, two hydroxyl groups are added in across the double bond, and alkenes are oxidized on the treatment with called aqueous alkaline solution of the KMnO4 to gives the ethylene glycol. Okay, so ethylene plus 2 mole, we take the 3 mole of the ethylene and also 2 mole of the KMnO4 and also 4 mole of the water molecule. Okay, after this process, we get the 1 mole of the ethylene glycol, 2 mole of the 2 MnO2, then 2 KOH. Okay, so this is a hydroxylation process. Now we study the oxidation process of the hot KMnO4. So when the alkenes is heated with the hot KMnO4, solutions are carbon-carbon double bond, carbon attached with the double bond, and cleavage the formation of the carboxylation. Cleavage is like breakdown of the bondings. Okay, so formation of the carboxylation, carboxylic acid and ketone or CO2 occurs, depends upon the nature of the alkenes. Okay, so we take the first ethylene. Ethylene are react with the 4O oxygen in the presence of KMnO4, hot KMnO4 and KOH, then making the one formic acid and one further addition of the oxygen, making the 2 CO2 are liberate and 2 water molecule also liberate. This is a ethylene to formic acid formation. Okay, now we see the another example, that is a 2-methyl propene plus 4 molecule of the oxygen in the presence of same condition, that is a KMnO4 and KOH. KMnO4, that is a hot condition. Okay, so making the one propanone and formic acid. Okay, and then after this oxygen adding and CO2 liberate and one water molecule also liberate. So this is the oxidation with the hot KMnO4 solution. Okay, now oxidation with the para acids like epoxidation. So in this alkenes on the treatment with the para acids such as the perbenzoic acid C6H5 COOH in a inert solvent like CHCl3 and CCl4 gives the epoxide. So ethylene plus perbenzoic acid in the presence of CCl4 making the ethylene epoxide, that is a solvent, that is a epoxide. Okay, epoxide molecules like here ethylene epoxide and perbenzoic acid also removed. Okay, and then now oxidation with the oxygen or air. So in this process alkenes bond in oxygen or air to forms the CO2 or H2O. This process is called the combustion. Alkenes bond in the presence of oxygen or air to formation of the CO2 that and H2O. This process is known as the combustion process. Okay, so this process is a highly exothermic in nature. Okay, so here we take the one ethylene molecule plus 3 O2 molecule and generation of the in the presence of oxygen, generation of the 2 mole of the CO2 and then 2 molecule of the water are liberated. Then further preparation, that is alkenes react with the O2 in the presence of the silver as a catalyst to forms the epoxide. Okay, so ethylene plus half molecule of the oxygen and then in the presence of silver at a higher temperature, that is 573 degree Kelvin. Okay, and then making the epoxy ethane. So this is the alkane react with the O2. Okay, then addition of the fourth one, that is addition of the hypohalous acid. Hypohalous acid, that is HOX. Okay, so first we formation of the hypohalous acid. Hypohalous acid such as the HOCl, then HOBr react with the water and formation of the corresponding hypohydrin. So we first the hypohalous acid making. So here X2, that is halide molecule plus halide molecule are react with the water molecule and making the one hypohalous acid and one hydrogen halide are removed. Okay, then alkenes react with the hypohalous acid and making the halohydrin. Okay, so this is a hypohalous acid addition. Now we study the fifth method, that is the addition of the water. So generally water does not readily to added to most of the alkenes. However, some reactive alkenes do add water in presence of the mineral acid to form the alcohol. Okay, a mineral acid to forms the alcohol. So methyl propene are added plus methyl propene are reacted with the water molecule in the presence of H plus, that is mineral acid, and making the methyl propanol. Okay, so this is the addition of the water reaction. Now we learn the 6th number reaction, that is a cold concentration plus cold concentrated H2SO4 sulfuric acid added to alkenes to form the alkyl hydrogen sulfate. So first we take the ethylene plus H2SO4 in a cold and concentrated condition. Okay, and making the one ethylene hydrogen sulfate. Okay, so this is a 6th number method. Now 7th number method, that is a hydroboronation oxidation of the alkenes. Okay, so here first we make the diboron, then added further alkenes and making as a monomer and making the trialkyl boron. Okay, so trialkyl boron having 3 alkyl groups. Okay, and then if we first we take the ethylene plus 1 boron, so making the ethyl bromide. Okay, after the further addition of the alkenes, making the diethyl boron. Okay, it's having a 2 alkyl groups. Then further reaction with the addition of the alkenes, making the triethyl boron. So triethyl boron having 3 monomers of the alkyl chains. Okay. So now last one, that is a oxymercuration reaction. Okay, so alkenes react with the mercuric acetate, that is CH3COO2Hg. Hg is a mercury, so mercury acetate in a tetrahydrofuran, that is THF solvent to forms the adducts the which upon the reduction of NaBH4 in the basic medium gives the alcohol. Okay, so here first we take the 1 butene in the presence of mercuric acetate in the and THF, making the 1 intermediate, that is adduct, and further reaction are followed with the sodium borohydrate and making the 1 alcohol, that is butanol. Okay. Now we study the application, another topic, that is application of the alkenes. So first application, that is a alkenes are used in a manufacturing of the plastics. Okay, and then second one, that is a lower alkenes are used as a fuel and illuminants. Okay, and then third one, that is the alkenes are used as a raw material for the manufacturing of industry chemical like alcohol and aldehyde. That is a raw material. Alkenes are used as a raw material to making alcohol and aldehydes. Okay, in industries level. Then fourth one, that is these are also used for the manufacturing of the wide variety of the polymers like polyethylene, then Teflon and PVC. Okay, and then fifth one, that is the lower alkene like ethylene is used as a general anesthetic and artificial ripening of the fruits. Okay, artificial ripening of the fruits. A lower number alkenes are used as a artificial ripening of the fruits and also used as a general anesthetics. Okay, then sixth one, that is ethylene, also used for the synthesis of the ethylene glycol, which is used as a antifreezing in a car. Okay, then seventh one, that is propene is used in a synthesis of the vinegar, propanol, then glycerin, then acetone, then phenols. Okay, then eighth one, that is eighth property, that is propene is mainly used for the production of poly or propylene and various oxidation products such as the butanol, acrylic acid, then acrolein, then acrylic acid ester, then allyl chloride and epichlorohydrin. Okay, then ninth one, that is butadienes used for the production of various synthetic rubbers such as styrene, butadiene rubber and styrene and butadiene rubbers. Okay, and then high resistance, last one, that is a high resistance polymer Ricor and intermediate for the synthesis of the nylon and are prepared from the butadienes. So here we complete our third chapter, that is alkenes. Okay, so thank you to all.